Lesson 47, graphing exponential functions. Does it have to do with this lesson?
Well, I was just gonna ask if I could go ahead and do this.
Okay, yeah, I'm sure that will help. Okay, an exponential function is where your variable x is in the exponent. So x is a real number. A cannot equal 0. B has to be greater than 0. And also not equal to 1. So b has to be greater than 0, not equal to 1. A can't be 0, and x is a real number. So let's see, here's what it looks like. Exponential y equals b to the x. Okay, when x is 0, what's y going to be? Every time? Yeah. 1. Okay, so we will have a 1 here. And then when x is -1, you're going to have a reciprocal of a number b that's greater than 0, so it's going to be a fraction. So it's going to be somewhere down here. Let's say b is up here. When x is 1, y will be equal to b, because b to the first power is just b. So at 1, you'll be at that number b. There is a vertical asymptote on the x-axis. So you will keep getting fractions closer and closer to x, the x-axis, closer and closer to y equals 0, as your x goes into the negative numbers, but it will never cross. So the x-axis becomes a vertical asymptote. And by definition, an asymptote is a line that a graph approaches but never touches. So the line will continually, or this graph will continually get closer to the x-axis but never touch it. And that also means it won't cross it. Tan?
What happens when it's like 1/3?
You mean the...
X.
Oh, if it's a fraction, no, if x is 1/3, then you're going to be 3 to the 1/3 power. You'd be like the cubed root of whatever number you have. So it's going to be along this part right here. Okay. So let's just graph y equals 3 to the x power. So we know when x is 0, y is 1. When x is -1, y is 1/3. When x is 1, y is 3. And then you connect those 3 dots in an exponential looking graph. When we find our domain and range, so domain will be all x's such that x is contained in the real numbers. So that just means x can be any real number. You can plug in any number for x along this axis. The range is y such that y is greater than 0. You would not put equal because you're never going to touch that x-axis. And the asymptote is an equation of the line y equals 0. Yes, Tim?
So, with the asymptote, last year we did that. You draw the line in between.
Oh yeah, with the dotted line.
Uh-huh.
Yes, you always dot the asymptote, but in this case, if the asymptote happens to be one of the axes, then we don't dot the axes.
Okay, and where's the other one?
There isn't another one.
I thought there was 2 asymptotes.
Mm-mm. It looks like there's going to be, but no, it'll continue at a slow rate, but it will continue to get bigger.
Okay.
Yeah. So to graph this one, if x is 0, we know that y will be 1. If x is 1, in this case, y will be 1/3. And if x is -1, then y will be 3. So then it goes basically the other way. The asymptote is y equals 0. The domain is all values of x such that x is contained in the set of real numbers. The range is all real numbers y such that y is greater than 0. So notice we have the same domain and range. And this particular graph is just a reflection of y equals 3 to the x power. So it just reflected there in the y-axis. Yes, Carter.
So will the asymptote always be y equals 0? Could you like add something to it to make the, like for example,
Oh, yeah.
you can make the y-intercept different?
Yes, yes. If you can, yes, if you raise it up or, wait, let me think about this for a minute.
Because you could have like
Oh, yeah,
y
yeah.
equals 1/3
Mm-hmm.
to the x plus 3.
Plus 3, and then,
It would still be the same equation, it's just at 3, and then it would take it longer.
so y equals 3 would be the asymptote.
Y equals 3.
Because this would never be equal to 0.
Yeah. Wait, can I say that one time?
So the asymptote would be y equals 3. It would be a dotted line here. So it would come up here like that.
Okay, that's what.
Yeah.
Okay.
And it would go up to 4 when x is 0, right? Because if you add 1 plus 3,
Oh,
you'd get
yeah.
4.
Okay.
So then, yeah, so whatever you add or subtract is now your
But
asymptote.
then like how it move like side to side.
I'm going to show you that next. I'm going to give you all the like information that you need to know to be able to graph. So the parent function is y equals b to the x power. Which we graphed earlier. Yes.
Okay, we'll go back for like 2 seconds.
No, not right now, but I will at the end.
Wait, and I have another question. And so the asymptote is always y equals 0?
No.
No?
Okay, so y equals a times b to the x. So we're just going to talk about what a coefficient will look like, what it will do to your graph. Tan?
Okay, so why can't b be negative? Or like
Then it won't be exponential. Because it will be a graph that switches from negative to positive if x is an odd number. So
what would that be then?
that's why we don't have b negative. It won't be an exponential function. So we're just only talking about exponentials right now.
Okay.
It would be a discrete.
Oh,
this continuous function. So this is going to give you a vertical stretch. And then if a is, if the absolute value of a is between 0 and 1, that gives you a vertical compression. And if the value of a is less than 1, it's a reflection in the x-axis. A reflection in the, wait a minute. I think that's bothering me. So it's if x is less than 0, so I wrote that wrong, because if it's a fraction, it's going to be a reflection in the y-axis. Like we did over here, we did the fraction, and that's a reflection in the y-axis. So if it's negative, that's when it flips down underneath the x-axis. So, okay. Then if we can have a shift up and down and left to right. So if you have a number subtracted from x in your exponent, it's going to shift horizontally h units. So remember that if you see a minus sign, it's going to be shifting right. And if you see a plus sign, it's going to be shifting left. And then it will shift vertically k units. So if you see a plus sign, it's going to shift up that many units. And if you see a minus sign, it will shift that down that many units. So that's it for the